find the volume of a three-dimensional object, you will use one of two equations. The equation you use will depend on the shape and the direction of the sides going upward. If the sides go straight up, like in this cylinder, then the equation you use is the area of the base times the height. In this case, my base is a circle, so the formula I use for area is pi times my radius squared. Or the area of my base is going to be 64 pi. And then to find my volume, I will multiply that by my height of 7. If my three-dimensional object is a box, then I find the area of my base, which in this case is going to be 6 times 5, and then I multiply that by 7. So the area of my base is 30, and my height is 7, so my final volume will be 210 cubic centimeters. If the direction of your upward sides point inward, such as in a pyramid or a cone, then to find the volume, you start with the same equation, the area of your base times your height, but then you take that answer and you divide it by 3. So in this case, my base is a triangle. So I'm going to use the equation that the area of a triangle is 1/2 times the base of my triangle times the height of my triangle. In this case, the height is referring to the 4 relating to the triangle and not the height of the overall pyramid. So the area of my base triangle is 1/2 times 3 times 4, or 6. So then the volume of my pyramid is the area of my base, which is 6, times my height, which is this other 4, and then I take that answer and I divide everything by 3. So my final answer is 8, or 8 cubic miles. A question may ask you to find the total surface area of a three-dimensional object, and that's the area of all of its individual sides added up. To find the total surface area, you usually have to break a three-dimensional object into its separate parts. So if we imagine this cylinder as, say, a soup can, you can see I really have 3 shapes. I have a circle on the top, I have a circle on the bottom, and then I have like the label of a soup can that wraps around the soup can. If I were to take off the label of a soup can and unwind it, I would see the label actually forms a rectangle. And the tops and the bottoms, well, they still form circles. So to find the total surface area, I have 2 circles and 1 rectangle. To find the area of my rectangle, I'm going to need to know the length and the width of my rectangle. The problem tells me the height of my rectangle, but it doesn't tell me how long it is. But if I look at my drawing and trace around the length of my rectangle, I can see the length of my rectangle is actually equal to the circumference of my circle. So if my circles had a radius of 4, that means the length of my rectangle must be equal to 2 times pi times the radius, or 8 pi. So the area of my rectangle is going to be the height, which was 7, times the length, which was the circumference of my circle, or 8 pi. So my final area of my rectangle is 56 pi. To find the area of my circles, I just use my standard area circular formula, or the area is equal to pi times the radius squared. Or in this case, the area is equal to 16 pi. So my total surface area would be 56 pi for the rectangle, 16 pi in one of the circles, and 16 pi in the other circle, giving me a grand total surface area of 88 pi. To find the total surface area of a cube, simply imagine that you're unfolding a cardboard box, and you can see that there are 6 sides of my cube that all form 6 individually equally sized squares. So I really only have to find the area of one of my squares, and then I can multiply that by 6. So the area is just going to be a base of 9 times a height of 9, so I get a total area of 81, and then I'm going to multiply that by 6 to get the area of all 6 of my squares combined. So my final total surface area is going to be 6 times 81, or 486. While it's not very commonly tested, you should be aware of the total surface area and the volume of a sphere. The volume of the sphere is going to be like the air in a basketball, and that equation is the volume of a sphere is equal to 4/3 times pi times the radius cubed. The surface area, which is all of the orange you see on a basketball, that's going to be equal to 4 times pi times the radius squared.